Hey everybody, we're going to end the year here with some data analysis stuff. So today we're going to talk about box and whisker plots. We're going to talk about how to make one and then how to tell if a number is an outlier or not. So box and whisker plots are a way to organize sets of data so that we can see percentages. We can see what they're called as quartiles, what quartiles a number would be in. And the first thing we need is obviously a set of data, which I have written on the board here. It does need to be in order as well. That is important. So I already took the time and put this data in order. This data is a random survey of the age of people who are at a park. Okay, so it goes all the way from 3 to 65, and we're going to talk about how to kind of set this up. All right, so there are 5 things you need to make a box and whisker plot. You need min, max, median, the Q1 and Q3. These are quartile 1 and quartile 3. And it's basically like where the 25% mark is and where the 50% mark is. And I'm going to kind of show you. So min and max, those are easy. So this is 3, this is 65. Median, remember, is the middle, and that's why we had to put it in order, because we want to find out where the middle of our data is. So you can cross them off or use your fingers. But our middle number here is 14. That's the median age at the park. Okay? Then, for quartile 1, quartile 3, you just find the middle of what you have left. So you do not use the median, okay? You use everything to the left of the median, and then we find the middle here. So notice that it's in between 2 numbers. To find that, you're just going to add these 2 up and divide by 2. So 4 plus 6 is 10. 10 divided by 2 is 5. So my quartile 1 is 5. And we do the same thing over here. 23 and 26, you add them up, which is 49 divided by 2. And that is going to be, what is that going to be? 24.5, right? 24 and a half. So those 5 numbers, also known as the 5-number summary sometimes, are basically what you're going to need to make your box and whisker plot. All right? So once we have those 5, I'm going to kind of use this side of the board, so you won't get to see me, but that's okay, I'm still here. You're going to make a number line. And depending on your data, I think going by 5s looks like it's pretty good for us. So we're going to go from 0, 5, 10. I'm not going to have room, am I? Let's go by 10s. Just because I don't really feel like moving down the board here. So 0, 10, 20, 30, 40. That way it all fits right there. So we go from 0 to 70. That way we can put these 2 lines on there. And then what you do is you just put a line at every spot where you wrote a number. So 3 is going to be, I don't know, approximately here. There's 3. 65, right in between those 2. 14 is down here, not quite in the middle. My Q1 is 5, that's awful close to 3. And then my Q3 is 24 and a half, that's about at 25. So there's 5 lines that we make. The middle 3 we connect and we make a box. The ones on the end are our whiskers. So we just connect from the middle of the box out there to the whiskers. So let's talk about what each of these spots is talking about here. Between this line and this line, 25% of our data falls between 3 and 5. All right, this is a really good way to show percentages of your data, right? So I know there's a very big chunk of my data, 25%, that are very small children. In fact, the next 25% would be inside this box right here, and that percentage would be from 5 to 14. So I know that 50% of my population in my survey is 14 years and younger, right? And then this is the third quartile, the third quarter, if you will. 25% of my data is in between 14 and 24 and a half. And then this whisker is really long. So the last 25% of my data is in between 24 and a half and 65. Now that's a pretty big spread. When you see a big whisker, or even a big box, just a big spread, that's telling you that your data is more spread out, right? If it's condensed, we have a large population in a very short area. Sometimes you might not even have a whisker because the lowest number is the same as the first quarter. You have a lot of people the same age, right? If it was a kindergarten classroom, for example, you wouldn't have a whisker. They'd probably be really, really close. When we see a long whisker, we wonder if that means there's an outlier. And an outlier is just a number that doesn't fit the rest of the data. That's kind of skewing some things. So I'm going to show you guys how to do that. Let me focus it back over here. So to find the outliers, the first thing you do is you find the IQR, which is the interquartile range. And the interquartile range is just Q3 minus Q1. So for us, we would just do 24 and a half minus 5, and that would be 19 and a half. Like so. Cool. Then step 2, step 2 to find an outlier is going to be take that IQR. Here, this is 1. Step 2, do your IQR times 1.5. Basically, in order to be an outlier, something has to be 1.5 times the range of the box away. So we're going to do 19.5 times 1.5. And that gave me 29.25. So that's the number that we have to check to see, is something in fact an outlier? Okay? So when you check it, you're going to check both sides. So you're going to do Q3 plus 29.25. If there's anything bigger than that number, it's an outlier. And then you check the smaller numbers also. So you do Q1 minus that number. If there's anything smaller than that, then that is an outlier. Now, obviously, we're probably not going to have a small outlier here, but we might have a big one, right? So let's check our numbers. So we're going to plug Q3 in here. So 24.5 plus 29.25. Is going to be, whoa, that was wrong. Oh, I think it times 29.25, there we go. Is going to be 53.75. So anything larger than 53.75 is an outlier. So when we check our data set, we do in fact have one. 65 is going to be an outlier because it's bigger than this number. And then we also have to check Q1. Now, Q1 is 5, and 5 minus 29.25 is obviously pretty small. Negative 24.25. And in order for something to be a lower outlier, it would have to be smaller than negative 24. Obviously, we're not going to have that. But you still want to show that you're checking both ends of this thing to see. I'll put a little arrow down. Anything smaller than that would be an outlier. So we do have an outlier. 65 has been proven to be an outlier because it is over a box and a half away from our Q3. I think that's kind of everything for box and whisker plots. Yeah, we're going to kind of do a little bit of data practice every day, and I'll kind of help you from there, okay? All right, cool. See you later.